Today we're talking about graphing linear equations. So we're going to see a few different ways to graph. So first, we are going to graph using the x and y intercepts. So to find an x-intercept, you set y equal to 0. So 2x minus 0 minus 6 equals 0. Okay, so we can ignore that minus 0, move that 6 to the other side, so 2x equals 6. So the x-intercept is 3. Okay, so right here is our origin, 1, 2, 3. That's our x-intercept. To find the y-intercept, we set x equal to 0. Okay, so we've got 2 times 0, which is 0, so we can ignore that. And let's move this y over. Since it's negative, we get negative 6 equals positive y. The y-intercept is negative 6. So our line looks about like that. So we'll find an x-intercept here. 4x plus 2 times 0 plus 8 equals 0. 2 times 0 we can ignore. So 4x equals negative 8. So x is negative 2. So the x-intercept is negative 2. And we'll find the y-intercept. 4 times 0 plus 2y plus 8 equals 0. 4 times 0 is 0. So 2y equals negative 8. So y is negative 4. So that's how you graph using intercepts. Next, we'll graph using the y-intercept and the slope. So the slope is the coefficient of x. The y-intercept is right here, negative 1/2. So this isn't the most convenient y-intercept because it's a fraction, but we'll go down 1/2. And a slope of 5 means go up 5 and right 1. Try that again. Okay, here we've got a y-intercept of 0 and a slope of 1/2. So we'll start at 0. And go up 1 and right 2. And I can go up 1 and right 2 a bunch of times before I've finished, before I've gone off the graph. So we'll do that as many times as we can. Down and left. If I can fit more points on the graph, I should, just to make sure I maintain that slope through the whole graph. And then find the 0 of the function. Okay, the 0 is the y-intercept. And this right here, this f of x, that's just function notation. It's the same as putting a y there. So 0 equals 4x minus 3. Okay, so I can move that 3 over. So x is 3/4. So the x-intercept is 3/4. That is a 0 of the graph. A 0 of the graph is anywhere that it intercepts the x-axis. Okay, so the y value is 0. From there, let's just follow the slope. The slope is 4, so 1, 2, 3, 4, and over 1. And we'll go down 4 and left 1. So in number 6, 0 equals 2x plus 4. So negative 4 equals 2x. So x is negative 2. So our x-intercept this time is negative 2. And the slope is 2, which is 2 over 1, up 2 and right 1. And down 2 and left 1. So way back to 1990, a 2-bedroom apartment at Remington Square Apartments rented for $575 a month. In 1999, the same apartment was $850 per month. Assuming a constant rate of increase, and a rate of increase, that is the slope. So assuming a constant slope, what will a tenant pay for that same two-bedroom apartment in the year 2000? So clearly we're going back a little ways with this. But we'll call 1990 year zero. When this began, the initial value, year zero, was $575. And then in 1999, year 9, the same apartment was $850. So our slope is y minus y over x minus x. So that would be $850 minus $575 over 9 minus 0, which is about $30.56. So on average, it was going up $30.56 every year. So the rent in the year 2000 you would expect that to be $30.56 more than it was in 1999. So that would be $850 plus $30.56. So you would guess it would be about $880.56.